Hello students, and welcome back to instruction video on your first lab assignment or first computer assignment. So we are on step 12. What we're going to do is create or add in a percent, let's go like this, percent frequency column. Let's make this all nice and neat. So there's our frequencies. What we want to do is create a percent frequency column to the right of the frequency column and calculate the percent frequency for each class. What we need here is a total. So to get a total, we can enter a formula, or we can go to this, once we are in that cell, the cell right below the last frequency, go auto sum, press enter, and center that. So we knew back in our calculations with IQ that there were 100 pieces of data, 180 pieces of data. So to calculate the percent frequency for each class, we would take that value of 3, so you can go equals 3 divided by 180. And we can press enter, and if we change that by clicking on this percent, we can change it to a percent instead of adding or multiplying it by 100. We can just change the format of that. Now, if we copy this down, we are going to get some errors. Because one thing in Excel, we're copying a formula down. The formula is B10 divided by, or B2 divided by B10. The next formula, because we copy down, is B3 divided by B11. We want it to be B3, that is correct, but we don't want the B10 to keep changing. In the original formula, it was divided by B10. We want that B10 to remain constant. And we don't want to have to add this into this formula 7 or 8 times. So what we do, go back to that first formula, go back into the formula bar up here, click somewhere around that B10, and we are going to, some keyboards allow you to enter or press F4 to put those dollar signs. If that F4 does not work, what I need you to do is right between the B and the number, it might be number 10, it might be 9 or 11, is right between the B and the number is to add a dollar sign. Go Shift 4, gives you that dollar sign. If you have a dollar sign in front of the B, so you have dollar sign B, dollar sign 10, that's okay. We just don't need that extra dollar sign. So this is what you need. You need B2 divided by B, dollar sign 10. Once again, B10, because that is my row where I have the totals. In the assignment you're doing, it might be B9 or B11. I guess they are even B12. Now we press enter. Now we can copy and paste this down, or if you move the cursor so it has that plus sign, we can drag this down, and voila, there are the percentages. Percent frequency needs to add up to 100%. So if you go into that cell right below your last percent frequency, click on auto sum, press enter, there it is, without rounding. So it's 100%, and let's center that. So it has the absolute frequency or the count being in the column B. It has the percent frequency as well. So we know that in the 100 to under 110 group, 24.44% of the sample or the data was in that range. So let's go back to our instruction sheet. We are on step 14. 14 says to return to the IQ sheet, and we're going to continue doing some calculations. We are going to calculate the mean. In brackets it says average, bolded, so that tells us the function. It's equals average, bracket, and highlight all your data. Same thing with the median. Equals median, bracket, highlight all that wonderful data. So in this case, Let's reduce the decimal place a little bit. Our mean is less than our median. So you should remember from the discussion in class that our data would be negatively skewed. There's lower values bringing down the average. Mean is less than the median. It's negatively skewed. Let's calculate the standard deviation. The function is listed on the instruction sheet. It's STDEVP. And we're going to highlight all of our data. Standard deviation of 14.631. That value, as we discussed in class, tells us how spread out the data is, but we need a different data set to actually make a comparison. So when you're doing your assignment, you can compare the standard deviation you calculate with the standard deviation that I have calculated. My standard deviation is 14.631. If yours is bigger than that, your distribution is more spread out. If it's less than that, then your distribution, your data distribution is less than what I have. So it tells us, especially if we're working with similar data sets, tells us how spread out a data set is compared to a different data set. So we also want to calculate the first quartile. First quartile is the same as the 25th percentile. So let's just put that in here just for our little learning tool here. This is the same as the 25th percentile. So that we are not going to find the percentiles on paper, because in order to do that, we have to sort out all these values in order. And that's just going to take too much time. So we know how to find percentiles on paper. So let's learn how to find percentiles using Excel. So the function is percentile equals percentile bracket. We highlight all of our data. We want the 25th percentile. So we can't just enter 25. We have to enter it as a decimal. Let's just highlight that, 0.25 gives us that 25th percentile. 25th percentile is 88. So someone who has an IQ of 88, they are have an IQ higher than 25% of the data of the people in the sample. Likewise, 75% are greater than that value. So let's do the same thing for this 75th percentile, or the third quartile. Highlighting all the data, bracket 0.75 gives us our 75th percentile. 75th percentile is 110.25. Of course, just to emphasize this again, your values are going to be different because we're working with different data sets. It's going to be close to the values that I'm finding. But don't be worried that your values are different. The only value that will be the same would be the OOC and the count. We're all dealing with 180 pieces of data, and the OOC is based on how many pieces of data we have. So the OOC number, 8.51, is going to be the same. So moving on, step 16, we want to calculate the IQR. The IQR is a difference between the third and the first quartile. So go equals, click on that value for the third quartile, minus click on the value for that first quartile, and there is the IQR, interquartile range. That tells us that the middle 50% of all the data has a range of 22.25 IQ points. Now, of course, that value is more significant if we are comparing it to another data set. Maybe this is a data set representing IQs for people living in one city versus another city, and we could compare standard deviation, we could compare IQR values as well. But the IQR is also useful in helping us determine if there's any outliers. So the outlier, this is step 17, we want to find the limits for determining if there are any outliers and list them if possible. or if there are any. So the outlier, we need to multiply the value, the IQR, by 1.5. So any formula in Excel starts with that equal sign. 1.5 times your IQR gives us a margin of 33.375. So let's enter lower limit and upper limit. Let's make those nice and neat. Hold that. So the lower limit is you take the first quartile minus that outlier. And the upper limit, we take that third quartile and we add the outlier. So the limit is 54.63. Anything less than that would be considered an outlier, and anything more than the upper limit of 143.625 would be considered an outlier. Look at your data, look at the min and the max. The max is 131. The max is not more than this upper limit. The min just above the lower limit. So in this case, no outliers. So if you did have outliers, you need to report them. If, for example, we had a minimum value of, say, 45. Oop, I don't want to do that. Let's just say there's a value of 45. 45 is less than this lower limit. So basically, outliers are going to be between will be less than 54.63 and, well, not and, but or greater than 143.625. So save your work. When you submit your work, put your name on the title of the Excel file, and then just drop that into the drop folder.